bacteria are probably the most intelligent amongst the microbes. They are known to send out these messenger molecules very, very strongly, intentional molecules that modify how we think, how we feel, how we behave, the food cravings that we have, and so forth. And maybe at this place I like to say one of the main recently identified mechanisms is what you also mentioned in your book, is is triggering the very using the coagulation mechanism of the host to protect themselves. And I like to just kind of say that here in the beginning, very early on, the way that works is this: the most easy place for bacteria to live, where they have the most food supply coming by them every moment, is in the bloodstream. Okay. The bloodstream is the nurturing fluid in our system. And so if I was a bug, I live in the bloodstream. The only problem with the bloodstream is that also the immune system is there. So that means there's a policeman are kind of constantly streaming by looking for you. Okay. And so you have to come up with a mechanism if you want to live the laziest life, and the more intelligent you are, you probably know that, you know, the less you work. Yeah? That's what we all do with our intelligence. We're seeking for ways how we can get the most money for the least effort. Yeah? That's a sign of intelligence. This is how most people use their intelligence. Bugs are the same way. Yeah? So they're using their intelligence to plan out where is the best food supply, where we can replicate the most, where is the most exchange with other microbes, where can we copulate the most. You know, it's like the king in its own castle, you know, where the food comes in on big trays, you know, sort of, and you're protected. The only missing thing there is how can we protect ourselves? If we live in the endothelium of the blood vessels, where all the nutrients are, how can we protect ourselves? And so the bugs have developed a simple strategy that trigger the host's coagulation system, not the immune system. Yeah, you use that term too much in here. Okay. Yeah, not the nervous system. They trigger the coagulation system of the host to put down a blanket of fibrin on top of them. So here's the blood vessel wall, the endothelium. Inside sit the bugs, and on top of them lays a blanket of fibrin, and this blanket has pores in it that are big enough to let the nutrients come in and are big enough for the waste products to kind of go out, but the windows, the pores are too small for the cells of the immune system to go through. It is very much the same as a mouse that sits on this side of the mouse hole, okay, and the mouse hole is big enough for the mouse to go in and out, but it's too small for the cat to fit through. So the cat sits out here waiting to get to the bugs, and the bugs sit in here and kind of say nani nani boo boo, yeah, and get the nutrients coming in without any problem. The trouble with that mechanism is that the exchange of nutrients in the body has to go from the bloodstream through the blood vessel wall into the tissue that's beyond that. And the research, there was a study published 2 years ago, shows when we don't have that fibrin coat lining the blood vessels, it takes for a molecule to oxygen to leave the red blood cell. You know, the red blood cells are carriers of oxygen, okay, and in the periphery, like in the brain, they're supposed to give off the oxygen to the brain tissue. Okay. And usually the transport from the red blood cell through the blood vessel wall into the brain takes 2 seconds. If the fibrin coat is there, it takes 5.4 minutes. 5.4 minutes for one oxygen molecule to make its way from the red blood cell into the tissue. And that explains why the kids, you know, with the chronic infections are acidic in their connective tissue, with all sorts of secondary metabolic problems, and why they can't get well. And so one of the main strategies in that case has to be to dissolve the fibrin coat. Yeah? This is where that comes from. Yeah? But going back what we're discussing right now is just the main sources of neurotoxins. So there is the heavy metals, there's the mycotoxins, then there is the endo and exotoxins and neuropeptides from pathogenic bacteria, and then fourthly and lastly, there is the environmental toxins, the man-made toxins other than heavy metals, like the PCBs, the PBDEs, that's the flame retardants that are used in your sofa, on your couch, and in your computer. There is the outgassing of carpets in the home. They're called VOCs, volatile organic compounds. There's about 600 of them that come out of every carpet that you put in the house. There is the outgassing of paints. There's an automobile exhaust with the petrochemicals. There's the spraying of insecticides, pesticides, and all those things. Those I list together as one category. We call them xenobiotics, to have one word that sort of covers the whole thing. So there is 4 major sources of neurotoxins. And now I want to give you my theory on autism based on my experience with it, which is very simple. There is a relationship between toxins coming in to the body and toxins leaving the body. If more toxins on a daily basis are leaving the body than come in, the person stays healthy. If more toxins come in than leave the body, the person will get sick. And my simple theory on autism is an autistic child is one where this relationship has been in the early stages of development that more toxins came in than left. Period. No other theory. Very, very simple. Now, when we look at what are the mechanisms that are there for the excretion of these toxins, that is something we have to spend some time in the book on. And the other one, what are the mechanisms by which toxins come in? These are the 2 only relevant issues that look at the causation of autism. Now, I'm just going to give an overview here. So, we want to look in the book at, and you've done that beautifully. I think it needs to be, in terms of the structure, sort of like, we have to put all these elements together in a couple of pages. What are the mechanisms by which toxins come in? Where do they come from? Which are these 4 sources? We need to look at them and they clearly list them. Sort of here's the sources where the heavy metals come in. It can be
nice graph.
Exactly. According to the study, we have to look at it's in the earth, it's in the air. It's when you live close to an old mercury mine, every pine tree in the area is giving off on a dry, sunny day mercury vapor. And so we have to look at that. We have to look at the molds in homes, the destruction that they cause. This is all looking at what comes in. We have to look at the pathogenic microbes. They only grow in the system if there's immune suppression.
Right.
So this is where the immune system comes in, which has been overrated in autism and has been talked about too much. So I want to minimize or correct it a little bit.
Okay.
One of the 4 components of toxins coming into the body has to do with the immune system.
Okay.
And then the 4th one is all the exposures from these other sources, which you've also have listed beautifully already. But we want to put it all together.
Okay.
Then we want to look at what are the mechanisms by which the body can excrete toxins. And I will go over that in a moment. And then, of course, we want to look at what's in the middle. Who is this person? That has those 2 things going on. And this is sort of where it comes in, where we need to look at the genetics, and where we need to look at what I call the 7 factors of health. This is the family history, the psycho-emotional issues are there, geopathic stress, structural abnormalities, and so forth. Where we go into that later.
Okay.
But in terms of the actual causation of autism, it's the balance between incoming toxins and outgoing toxins. And if this is out of balance, there's damage in the middle. And then what most treatments of autism have done so far, they look at the damage, at the secondary stuff, and trying to fix the damage without addressing the incoming toxins and the outgoing toxins. Yeah? So when we look at defects in methylation, when we look at for example, a treatment where we look at the urine or serum amino acids and we try to balance the amino acid pattern because it's off. If we're trying to look at the red blood cell minerals and try to get a little bit more selenium in, a little bit more zinc in there, if we try to give digestive enzymes or so, what we're doing, we're trying to fix the secondary damage that has been caused by this primary process. So in the book, I would like to distinguish between the primary causes of autism, what is this primary thing that occurs, and then all the secondary damage. Yeah?
Yeah.
And so let's look, so we looked at the toxins coming in. Let's look at briefly at the way that they're leaving the body.
Okay.
You know, the simple way, and I would love you to expand on that in your language, because you have beautiful, colorful language in saying these things, that each cell has a number of biological molecular pumps that can pump out toxins from the cell. Yeah? Similar to, you know, when you have a boat, you know, like I used to be into rafting, and there is now self-bailing rafts, and there is rafts where you actually, you know, you take a bucket, and every time a wave kind of, when you do whitewater rafting, you go through a class 5 rapid, the boat fills up with water, and you have to sit there and bail out. You know, this is the non-self-bailing type of boat. And in the self-bailing boats, half the time the self-bailing mechanism fails, and you still have to kind of use the buckets. Now, this is exactly the same in the cell. You know, the toxins come in, and then there is a number of mechanisms by which the cell kind of throws the stuff back out. And it's important in terms of the treatments that we're offering or that we've created to understand what those biological molecular pumps are.
Okay.
You know? And this is quite honestly the area where very little is known yet, relatively little is known. But there's a few of them that we do understand. I'd like to just kind of mention them here now at the beginning. You know, and we may revisit that later on or not. And so the one of the well-known pumps is the glutathione mechanism. You know, glutathione is a dipeptide that has a, oh, maybe I should start different. Many of the pumps are based on the so-called sulfhydryl mechanism. Sulfhydryl groups are chemical groups that have a sulfur molecule and a hydrogen molecule, and it carries a negative charge, and this will attract positively charged ions that bind to it. And in that state, when glutathione has bound a positively charged particle, in that state it can move very swiftly through the cell wall back out and can carry this positively charged particle out of the cell. Now, the most well-known positively charged particles are heavy metals. Yeah?
Okay.
They're all positively charged. Mercury is a Hg1 plus or 2 plus. It exists in 2 forms. Aluminum in 3 forms, actually 1 plus, 2 plus, and 3 plus. Cadmium, 2 plus. And there is a number of metals that are referred to as sulfhydryl affinitive metals.
Okay.
Yeah? That's mercury, lead, cadmium. Those would be the 3 most common toxic ones, but
Okay.
copper, zinc also belong in this category. And glutathione is there to simply measure the excess of positively charged metals in the cell, and if they're there, it binds to them, it takes them out of the cell.